One application we see a lot of in real life for percents is percent change. So if we hear a statement like healthcare costs have increased 5% since last year, or you're going to receive a 2% increase in your salary, those percent increases are percent changes. We could also have the same thing with decrease, right? We're going to decrease the number of Math 119 sections by this percent. So increase, decrease, change, they're all the same thing. So I'm going to go ahead and put up here increase, decrease as well. There is one slight difference, and we'll talk about that with our first example. So just to talk a little bit, we have an actual definition here. To find the percent change, you take the new value minus the old value and divide by the old. I like to think of this more as the difference over the original, and we make that into a percent. This works a little bit better for the increase decrease wording, which I will show you why with an example. So the example happened to be, I was actually reading a article about percent change and percent decrease and percent increase right before I made this. So I'm just going to grab examples straight from it. So in the article, they had this sweet graph showing the U.S. murder rate, and they were talking about what it was doing recently. So they had all the murder rates from 1960 to 2015. So I'm going to choose the worst murder rate. In 1980, the U.S. murder rate was at its highest. The murder rate, the highest it's been since it's been recorded, was a 10.20. So that means for every 100,000 people, 10.20 of them were murdered. All right. Oops, I didn't write was. Yeah, pretend that word is there. Cool. So, and in 2015, the most recent date on this graph, the murder rate was 4.90. So we have clean this up a little bit, random periods and things that don't make sense. All right, so we got these two. What that is, oh well, the question we could be asked is, what is the percent change in murder rate from 1980 to 2015? All right, so this question is giving everything away from us. If we want to use the formula, that first formula, new minus old over old, we can see, okay, here's our old, here's our new. These are the when they are, and then we actually have the values from each of those, right? So there's our new value, there's our old value. We've got them both. And then we just plug right into that formula. So the formula was new, I'll even rewrite it, minus old, all over old, times 100 to turn it into a percent. So 4.9 minus 10.2, all divided by 10.2, times 100. So I'm going to do this in my calculator in 2 steps. I'm going to do this and then multiply my result by 100. And in fact, actually, I'll do it in 3 steps. I'm going to do the numerator first because I'm not working with a sweet calculator with that fraction bar. But this is one of those things I would bust out your calculator, make sure you're getting the same answer as me, because it's a really easy one to make a simple mistake on, and we'll talk about what that mistake is. So if you multiply all this out, you should get 51.96%. A common mistake that students make when they're putting this on their calculator, if they do it all at once, is they'll do something like this. If this is what your calculator looks like, you've made a mistake already, because your calculator is going to do the multiplication first, multiplication and division first. So it'll actually do this. In your answer, it would have given you 3.9, which doesn't make any sense, right? So if you do this, one thing I would do, since you should all have that 36x, is I would enter it with the little fraction button, so you actually have something that looks exactly like that. If you don't have the fraction button, using a graphing calculator, either do it in 2 lines or use parentheses to tell this thing that that is your numerator, that that whole thing is divided by 10.2. Either of those is okay. That this is our answer. We should get that the murder rate 1 decreased, right? Because this is going down. So we have that negative. And then it was cut almost in half, right? So it's exactly what we're seeing here, about 50% of a decrease, cut almost in half. Now, there is a difference here. This question could have been asked is, instead of everything else, instead of saying what is the percent change, I could have said what is the percent decrease. And here's the difference in our wording. When we have decrease written here, we don't need to write the negative because that's a double negative, right? That makes it a positive. Decrease already implies a negative. So if you're asked for this, that's when you just want to do your difference over your original, or just whatever you get out, just ignore it and just ignore the negative and just say, okay, cool, it's decreasing, check mark with that negative. All I need to report out is that the percent decrease was 51.96%.